Hello and welcome to Astronomy Daily, your cosmic companion for everything happening beyond our atmosphere. I'm Anna, and I'm thrilled to guide you through another journey across the stars and planets that make up our fascinating universe. Today's episode is packed with groundbreaking developments that showcase humanity's relentless pursuit of space exploration and understanding. We've got a stellar lineup of stories that highlight both our achievements and the mysteries we're still working to solve. First, we'll explore exciting news about Europe's first Mars rover, the Rosalind Franklin, which is back on track after facing significant challenges. The mission has found new life with fresh partnerships and ambitious plans to search for signs of ancient Martian organisms. Then, we'll rocket over to SpaceX's continuing evolution as they develop their next-generation facilities. From the construction of Orbital Launch Pad B to the demolition of High Bay making way for the impressive GigaBay, Elon Musk's space company isn't slowing down its revolutionary pace. Our third story brings us closer to home, but with potentially far-reaching impacts, as we cover a surprising X-class solar flare that recently triggered radio blackouts across the Americas. We'll discuss what this means and why solar activity forecasters are keeping their eyes on the sun in the coming weeks. Next, we'll dive into the fascinating Venus life equation, a new framework scientists are using to assess the possibility of life on our nearest planetary neighbor. Could Earth's evil twin harbor life after all? Finally, we'll meet the crew of SpaceX's groundbreaking Fram-2 mission, set to make history as the first human spaceflight to pass over Earth's polar regions. So strap in for the next 20 minutes as we explore these cosmic frontiers together on Astronomy Daily. Let's get started with today's news. Europe's first rover to be sent to another planet is getting a second chance at making history, with the Rosalind Franklin mission now firmly back on track for a journey to Mars. This ambitious European Space Agency venture faced a significant roadblock when Russia invaded Ukraine in 2022, forcing ESA to suspend its partnership with Roscosmos just months before the planned launch. Rather than abandoning the project altogether, ESA reassessed the mission and secured additional funding to ensure this groundbreaking scientific expedition would still reach the Red Planet. The rover, named after the brilliant scientist who played a crucial role in discovering the structure of DNA, is designed to probe whether life once existed on Mars. What makes the Rosalind Franklin rover particularly special is its impressive drilling capability. While other Mars rovers have scratched the surface, this European explorer will retrieve samples from a remarkable 2 meters below the Martian ground. These samples could be up to 4 billion years old, potentially dating back to a time when Mars might have been more hospitable to life. With Russia no longer involved, NASA has stepped in to provide the launcher and several other crucial components, including the rover's radioisotope heater units. The mission is now targeting a 2028 launch with an expected arrival on Mars in 2030. In perhaps the most exciting development for the UK space sector, Airbus has been awarded a £150 million contract to build the rover's landing platform at their site in Stevenage, Hertfordshire. This project, funded by the UK government through the UK Space Agency, keeps a significant portion of this groundbreaking mission on British soil. Interestingly, Airbus isn't new to the mission. They built the Rosalind Franklin rover itself. But as project manager Caroline Rodier noted, getting the rover safely onto Mars presents an entirely different set of challenges. Landing on Mars is not an easy task, and the schedule is very ambitious as well, she explained. The landing sequence sounds like something from a sci-fi movie. The rover and platform will be enclosed in a capsule Rodier compares to a Kinder Egg, complete with parachutes and a heat shield. Upon entering Mars's atmosphere, the first parachute will deploy to slow the capsule to subsonic speeds. After that parachute and the capsule are jettisoned, a second parachute attached to the lander will engage. As the platform approaches the surface, it will fire powerful thrusters to ensure a gentle touchdown. The design requirements are exacting. The lander must slow to less than 3 meters per second before contact with Martian soil. Once safely on the ground, the lander will deploy 2 symmetrical ramps, allowing the Rosalind Franklin rover to select the safest path to begin its exploration. The rover itself is currently undergoing various upgrades since the launch window has changed, including enhancements to its guidance and navigation control systems. Paul Bate, CEO of the UK Space Agency, emphasized the significance of this mission. This is humanity defining science and the best opportunity to find if past life once existed on Mars. The ripple effects of space exploration discoveries extend far beyond the realm of space exploration, driving progress and prosperity across multiple sectors in the UK. The renewed Rosalind Franklin mission represents not just European ambition in space exploration, but also highlights the importance of international collaboration in tackling the greatest scientific challenges of our time. Meanwhile, at SpaceX HQ, while the Starship program continues its testing cycle between flights, SpaceX is making significant progress on expanding its infrastructure at Starbase in Boca Chica, Texas. The company is simultaneously developing its next-generation Orbital Launch Pad B, while beginning the demolition of the original high bay to make way for an impressive new construction facility. Construction teams have been hard at work on Orbital Launch Pad B over the past few weeks. In mid-March, they conducted a massive concrete pour for the flame trench floor, bringing in approximately 300 concrete trucks over a 26-hour period. This was followed by additional concrete work on March 27th for one of the two flame trench ramps. With the foundation taking shape, the next phase has begun with steel flame trench wall pieces arriving on site. These components will be bolted and welded to embedded supports placed in the rebar before the concrete was poured. Each wall section will eventually be filled with concrete, creating a robust structure capable of withstanding the tremendous forces generated during Starship launches. The walls installed on the flat floor will bear the immense weight of the orbital launch mount once it's in place. Progress is also evident on Pad B's chopsticks, the mechanical arms designed to catch returning rockets. After resolving some binding issues with the cable train that houses power and data lines, crews successfully raised the chopsticks to the top of the tower. Recent testing has included calibrating the primary actuators, with the chopsticks now demonstrating controlled side-to-side movement. Another milestone for Pad B was the operational testing of the first liquid oxygen pump and new exhaust system. Unlike Pad A, which vents excess propellant directly into the wetlands, Pad B features a more sophisticated system. A separate vent line directs gases into a duct with powerful fans that dilute the liquid oxygen or nitrogen, creating a plume of gas similar to a steam locomotive. In parallel with the launch pad construction, SpaceX has begun dismantling the high bay facility that has served the Starship program since late 2020. This structure, which helped assemble everything from SN9 through Ship 32 and several boosters, including the historic first stack of Ship 24 and Booster 7, is making way for something much more ambitious. The decommissioning crew has already removed the roof and bridge crane, with the entire structure being methodically disassembled piece by piece. Once fully dismantled, workers will excavate the foundation to prepare for GigaBay, SpaceX's next-generation Starship construction and servicing facility. The planned GigaBay will dramatically increase SpaceX's production capabilities with 24 workstations, featuring turntables for vehicle construction and dedicated work stands for final assembly and servicing. The facility is expected to have two main bays, each with its own transfer aisle for vehicle movement, and will connect to both the Star Factory and a parking garage for improved employee access. Perhaps most impressive are the planned 400-ton bridge cranes, equipment with 50 tons more capacity than the largest cranes in NASA's Vehicle Assembly Building at Kennedy Space Center. While the GigaBay represents a quantum leap in SpaceX's manufacturing infrastructure, patience will be required, as construction estimates suggest it will take between 18 to 24 months to complete after the high bay demolition is finished. These developments highlight SpaceX's commitment to rapidly scaling its Starship program, with infrastructure investments that will support a growing fleet of vehicles as the company pushes toward its goals of regular orbital flights and eventual missions to the Moon and Mars. Next up, our own star is in the news again. The sun has delivered a dramatic surprise to space weather forecasters with a powerful X1.1- class solar flare erupting from a newly emerging sunspot region designated AR 4046. This unexpected event triggered shortwave radio blackouts across the Americas, which happened to be on the sunlit side of Earth when the flare occurred. The solar event was particularly spectacular, featuring not just the intense flare, but also a remarkable filament eruption and coronal mass ejection, essentially a massive expulsion of plasma and magnetic field from the sun's atmosphere. Solar physicist Halo CME noted that while this particular CME may not be Earth-directed due to the sunspot region's position near the sun's east limb, that situation will change in the coming days. Solar astrophysicist Ryan French captured the excitement of the event, describing it as a beautiful solar flare and warning that the flare source region will rotate to face Earth in the coming week. Further strong solar activity is likely. This rotation is significant because it means any future CMEs from this active region would be more likely to impact our planet directly. For those unfamiliar with how solar flares are classified, they fall into 5 categories of increasing intensity: A, B, C, M, and X. Each step represents a 10-fold increase in energy output, with X-class flares being the most powerful. Within each category, numerical ratings further define strength, making this X1. One event powerful, but at the lower end of the X-class range. The radio blackouts experienced across the Americas demonstrate how these solar events impact Earth in real time. When a flare erupts, it releases X-rays and extreme ultraviolet radiation that travel at light speed, reaching our planet in just over 8 minutes. This radiation ionizes the upper atmosphere, temporarily changing its density and affecting high-frequency shortwave radio signals used for long-distance communication. As these signals attempt to pass through the charged atmospheric layers, energy loss from collisions with electrons can significantly weaken or completely absorb transmissions. This disruption is particularly concerning for aviation, maritime operations, emergency services, and amateur radio operators who rely on these frequencies. What makes this event particularly noteworthy is its timing within the current solar cycle. Our sun follows roughly 11-year activity cycles, and we're approaching what appears to be an unusually active solar maximum. With AR 4046 now on the scene and set to rotate into a more Earth-facing position, space weather forecasters and aurora chasers alike are keeping a close watch on developments. If subsequent eruptions occur when the sunspot is facing Earth directly, we could experience more significant impacts, including geomagnetic storms that might affect satellites, power grids, and navigation systems, but would also treat observers at high latitudes to spectacular aurora displays, potentially visible much farther south than usual. Next, a philosophical question for you to ponder. What drives us to explore the cosmos? While scientific curiosity certainly plays a role, our search for life beyond Earth remains the most compelling motivation. The thought that our planet might be the sole harbor of life in the vast universe is both humbling and disquieting, which is why scientists are increasingly turning their attention to an unlikely candidate: Venus. Despite its hellish reputation, Venus shares remarkable similarities with Earth in size, mass, and composition. Both planets technically reside within the habitable zone, though Venus barely qualifies. Their evolutionary paths diverged dramatically, with Earth maintaining its habitability while Venus succumbed to a runaway greenhouse effect. This stark contrast offers valuable lessons for understanding how similarly formed rocky planets can develop radically different environments. At a recent presentation during the 2025 Lunar and Planetary Science Conference, scientists introduced the Venus Life Equation, or VLE, a framework reminiscent of the famous Drake equation, but focused specifically on evaluating the probability of life on our nearest planetary neighbor. The VLE distills this complex question into 3 key parameters: origination, robustness, and continuity. Expressed mathematically as L equals O times R times C, the equation provides a structured approach to thinking about Venus's potential for hosting life, both historically and currently. Origination considers how life might have first appeared on Venus, whether through abiogenesis, life arising from non-living matter, or panspermia, where life arrives via interplanetary material transfer. Scientists now believe Venus may have enjoyed a period of temperate, watery warmth, coinciding with Earth's late Hadean and early Archean eons, precisely when life first emerged on our planet. This raises the tantalizing possibility that life could have gained a foothold on early Venus. Robustness examines the potential size and diversity of any Venusian biosphere over time. This depends on factors like the availability of essential KNOPS elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, as well as energy sources and the functional diversity of organisms. Evidence suggests Venus once had land-water interfaces, and possibly even plate tectonics, both critically important for life's development and resilience. Continuity evaluates whether conditions amenable to life persisted uninterrupted. This incorporates stellar stability, orbital parameters, geological processes, and the likelihood of extinction events. Could life that originated during Venus's temperate period have survived the planet's dramatic transformation? Intriguingly, at around 50 kilometers altitude in Venus's atmosphere, conditions remain surprisingly Earth-like in terms of temperature and pressure, fueling speculation about potential aerial microorganisms. Remember the controversial 2020 report of phosphine detection in Venus's atmosphere? While subsequent studies have questioned these findings, the discussion highlighted our ongoing uncertainty about what might be possible in Venus's clouds. The VLE, like the Drake equation before it, doesn't provide definitive answers. Instead, it offers a framework for organizing our thinking and identifying knowledge gaps. It helps scientists prioritize objectives for future Venus missions, including potential atmospheric sample return missions currently under consideration. Understanding Venus has implications far beyond our solar system. As we discover more exoplanets in habitable zones around other stars, the lessons from Venus become increasingly valuable. How many seemingly habitable worlds might actually be Venus-like rather than Earth-like? The VLE helps us formulate the right questions as we extend our search for life to distant star systems. Diana Gentry, director of the Aerobiology Laboratory at NASA Ames and lead author of the VLE presentation, emphasizes that we're constrained by what she calls the N=1 problem, having only Earth-based life as our reference point. Nevertheless, by establishing this methodical framework, scientists can systematically address the unknowns and uncertainties about life's potential beyond our home planet. As future missions to Venus take shape, including NASA's Da Vinci and Veritas and the ESA's Envision, the Venus life equation provides a coherent structure for integrating new discoveries into our understanding of planetary habitability, and perhaps someday answering one of humanity's most profound questions: are we alone in the universe? Finally, today, history is about to be made with SpaceX's Fram-2 mission, scheduled to launch no earlier than this coming Monday, March 31st. This groundbreaking expedition will mark the first time humans have flown over Earth's polar regions in space, charting a unique orbital path that has never before been attempted with a crewed spacecraft. The 4-day mission will utilize SpaceX's proven Crew Dragon capsule named Resilience, which has already completed 3 previous launches. This represents SpaceX's 6th private astronaut mission overall, continuing the company's pioneering work in commercial spaceflight. Fram-2 draws its name from a famous Norwegian vessel that explored the Arctic and Antarctic regions in the early 20th century, honoring a rich tradition of privately funded polar expeditions. The mission aims to combine scientific research with the historic achievement of human polar orbital flight. Leading this remarkable journey is Commander Chun Wang, a Maltese cryptocurrency entrepreneur who helped finance the mission. As co-founder of F2 Pool, a global Bitcoin mining operation, Wang represents a new generation of space exploration patrons. He's expressed a lifelong fascination with space, noting that, for the first time, a private person can plan and design their own very personal mission. Serving as vehicle commander is Norwegian filmmaker Jannicke Mikkelsen, whose expertise lies in capturing footage in extreme environments like the Arctic and open ocean. Her experience includes collaborating with Sir David Attenborough on 360-degree underwater documentaries, and working as payload specialist for the One More Orbit mission, which circumnavigated Earth via the North and South Poles. The mission will make additional history through pilot Rabea Roga, who will become the first female German astronaut. An engineer and scientist specializing in robotics and polar research, Roga is currently pursuing a PhD in marine technology at the Norwegian University of Science and Technology. Her background in extreme environment research makes her particularly well-suited for this pioneering polar orbital flight. Rounding out the crew is Australian polar explorer Eric Phillips as mission specialist and medical officer. Phillips brings decades of experience leading ski expeditions to both the North and South Poles. As co-founder and former president of the International Polar Guides Association, he expressed particular excitement about viewing Antarctica from space during a time when it will be fully illuminated. Fram-2 follows in the footsteps of other private SpaceX missions, including the Inspiration 4 mission in 2021, which was the first all-private orbital spaceflight, and last year's Polaris Dawn mission, which featured the first commercial spacewalk. Unlike SpaceX's Axiom missions, which visited the International Space Station, Fram-2 will be a free-flying mission in Earth orbit, focusing on its unique polar trajectory. The mission demonstrates the rapidly evolving landscape of commercial spaceflight, where private citizens and organizations can now design missions aligned with their specific scientific, exploration, and personal objectives. As Wang noted in his comments about the mission, these pioneering private efforts are trying to make the door wider so that personalized space missions become accessible to more people in the future. Well, that's quite a stellar lineup of space news today. We've covered some truly remarkable developments that showcase humanity's enduring commitment to exploring the cosmos. From Europe's ambitious plans to send the Rosalind Franklin rover to Mars by 2028, to SpaceX's impressive infrastructure developments with their new Orbital Launch Pad B and upcoming GigaBay facility, we're witnessing remarkable progress in our space capabilities. We also examined that surprising X-class solar flare that triggered radio blackouts across the Americas, reminding us of our star's immense power and unpredictability. The Venus life equation gave us a fascinating framework for considering whether our nearest planetary neighbor might host or have hosted life, with important implications for how we search for life throughout the universe. And of course, we looked at the historic Fram-2 mission, poised to become the first human spaceflight to traverse Earth's polar regions when it launches in the coming days. This private mission exemplifies how commercial spaceflight is opening new frontiers and possibilities that were once the exclusive domain of government space agencies. I'm Anna, and I've been your host for this episode of Astronomy Daily. If you're hungry for more space and astronomy news, I invite you to visit our website at astronomydaily.io, where you can find our constantly updating newsfeed and listen to all our past episodes. You can also join our community across social media platforms. Just search for Astro Daily Pod on X, Facebook, YouTube Music, Tumblr, and TikTok to stay connected with us and fellow space enthusiasts. Until next time, keep looking up. There's always something fascinating happening in our universe, and we'll be here to bring those stories to you. Thanks for listening to Astronomy Daily.